Hey guys, it's me, Mackie, and today I want to go over getting started with the Babylon Toolkit. First things first, we'll pop over to the GitHub repo for the Unity exporter, and that is at github.com/BabylonJS/Unity exporter. And as you can see listed here, this is where you have links to the documentation. You have links to where to download the editor, where to download the runtime, how to load the runtime on your host page or at runtime or in the playground. The Babylon Toolkit uses a scene manager class as the main driving lifecycle component. It has a bunch of static helper functions on there as well to give you that Unity-like style of game development. The main script component class is responsible for your lifecycle. So this is the class that's modeled behind Unity's mono behavior. So you get a lifecycle, you get an awake, start, ready, update, late, update, before physics step, after render loop, and reset and destroy. If we go down here, we can actually pop this open in a new tab. Here's an example playground of a script component that is a rotator. And as you can see here, we initialize the playground. We set up a few pieces of geometry on the scene. We create an instance of the rotator class. We attach that instance to the scene manager's lifecycle. And here's the details of the script component. We're only using the awake and the update function. So in the awake function, we set a starting position, and in the update function, we rotate the transform as we see over here, and we can dynamically change these at design time, and we hit the button, and now you see the effect. Now this is the same principle that Unity uses when you create a game object and attach a script to it, and these two lines do the same thing. So now let's just pop open to get our download. So we'll pop back over here and we'll go to editors. There's the package, the Unity package for the editor, and you click the download button. That will download your Babylon Toolkit package onto your computer. Then we will load up our new getting started project. We're going to use 2022.3.33 F1. That's the LTS version that the toolkit was built on. It's pretty much the safest version to use so far. We will make a new version when the next Unity comes out, but for now we'll just use the 2022 3.33. We'll do getting started. I already have that project created, so I won't create it now, but you just hit create project and we'll click it. Let that project load up, and let's just clean up our space a little bit, make room, and we'll get rid of this one for now. And now that our scene is open, the first thing I like to do is to set the project settings. So we will go to project settings, and in the player, I'll change this to my name. We'll make getting started. We'll have a little space in the product name there, and then we use the linear color space. The one thing that the toolkit does not support is reflection probe blending. So for all three layers, we're going to disable that feature. So we'll uncheck the use defaults and uncheck the reflection probe blending option. And that ought to do it. Now we're ready to load in our toolkit. So we will grab the package from our downloads, drop it in here, but you can just as easily select the assets menu and import it that way. We'll click all. We'll let it come expand all of the options or all of the files out of the package. It will recompile the Unity project, and you will end up with a new option in the menu for the Babylon Toolkit. So let's let it finish running up here. There we go. So now we have tools up here. Now down here, we're not even using these universal shaders right now. It didn't like something on the import of the packages from the render pipeline, but we're not using those. So we'll just clear those out. We'll go up to tools and we'll open up the scene exporter. That loads the Babylon Toolkit panel, and we'll dock that panel so that we can easily get to the options. Now on the script compilation, it's going to tell you want to do an npm install on this brand new project here. So get the compiler set up. So we're just going to open up the C# project so that it opens up in that folder. We're going to Control tilde to open up the windows in the root folder, and we're just going to go npm install. Now that that loads, we'll close out code, and we would either have to shut down Unity editor and bring it back up, or in this case we'll just hit the rebuild project editor button, which will force the project to rebuild the binaries itself, which will cause the node compiler to get recognized, and as you see now, it can detect the node modules and where our TypeScript module is. I'm just going to load ES6 too as well there. So we'll save that. Now the first thing that we're going to need when you create a new scene from scratch is lighting. If you don't have lighting, you can't even save the scene. So first thing I'm going to do is come over here, create a folder called project, and all the stuff for my particular project I'm going to stick in there. I like to keep the root folders clean. They just have some system folders in here, maybe some plugins that I use for other third-party components, but this one doesn't have any. We're just going to go into projects. We're going to create a couple of folders in here. One of them is lighting, so we can put our default lighting there. We'll create another folder called materials, so we can have materials, and then we'll create another folder just for this little project here called scripts, and it's only going to be one script in there. But in our lighting, we'll come over to here, and on our environment scene settings, we're going to say new there to create a new lighting. And then we're going to call this default, so we can use this over and over. And that's our default lighting. We're going to set it for subtractive. I'm going to use a GPU. We don't need to really monitor the progress. It'll bake faster without it. It'll also bake a little bit faster with the 1K maps. We're going to take off the compression, and we're going to use non-directional. Now that is our default light setup. We'll go to materials. We'll create material, so we create our materials the Unity way, and we'll call this Amiga, and then we'll select our material, and let's give it a texture of Amiga. Now from there, we're going to create a plane and create a cube, and on the cube we don't need any physics on that. We'll just do that. We'll take the Amiga material, drag that onto our cube, and then in our exporter, before we even put the script component on there, we'll do a quick check build on there. That forces the compiler to build in the very first time. It also creates a tsconfig.json. So now we see our component just like we would see it here. And there's our export. Now we're going to go back over here, come to the cube. Now we'll add a script component that our tsconfig has been set up. So we will go create Babylon Toolkit script component. This will be my rotator, if I spell it right. And then When you create a script component, it creates two files, a C# editor file and a TypeScript backing file. The editor file is what you use at design time to attach the component to the game object and assign properties to it. Those properties will get proxied to the backing class in TypeScript via the GLTF file. So we will select the cube, and we will come over here and we will drag my rotator onto the cube. Now when you double click it here, we haven't put any code on here. We are going to use this to add properties. We're just going to clean this up because we're only going to have one. We're going to use the auto keyword that tells it to use the automatic mechanism to update the properties of the same name in the actual backing class. So we'll create a public property called speed, and it'll be a float actually, and we can really get rid of that. So clean up our class. We'll take this public float and we'll come to our rotator class, and we will actually drop this in here and create the same property in the client side. And now since it had the auto keyword, it'll update automatically before your awake function runs. So now we can successfully use that property in any one of our lifecycle functions. To begin with, we're going to take this transform and we're going to grab its position just like we did in the other one, and we're going to set it to 1 unit in the air. Set it to 1 unit in the air, and then in our update loop, just like we did before, we'll grab the delta time equals this dot get delta seconds, which is a property of the script component to retrieve the time in seconds. I like to fully prototype use the strong type since I'm using TypeScript. And we'll return speed, which is a number, and then this dot transform dot add rotation. There's several different ways you can add rotation. It's probably the easiest, and we can just turn this into turn speed. And since we're not using any of the other functions, just like before, we can clean up the unused functions, and now we have a nice clean script component for the rotator, just like we had in the playground, but this time it is in the editor world. And when we pop back over here, it'll recompile. Give that a second. And then we have our script component with our speed set to 1. We'll just hit the build function. And we now have our cube lifted 1 in the air and spinning around at the speed of 1. We can change it in the editor, so we get the whole editor experience of creating not only our scene hierarchy, but how we create our scripts and how we interact with the editor properties of our script. So now it's spinning faster, and as you can see, we have our dynamic shadows and everything running in our scene. So that is our first script component and our first project.